Awesome. Hello guys, can you hear me okay? Got a yes?
Yep, you're fine.
No, fine, okay. It's okay. Welcome to session number 7 of IBM Systems Back to School. Today we're going to talk about basically three solutions that IBM has in its portfolio about on storage brand, and I hope you enjoyed. Just bear in mind that we're talking about three very dense products, so we are not going to cover them in depth. So already put in a disclaimer so you can set your expectations. And also, if you guys feel that it is interesting to deep dive in one solution or the other, please feel free to reach one of us, and we are happy to book that meeting, that session for you. The important message is that yes, we have a solution for very good solutions for unstructured data, and don't let any doubt stop you from doing project with us. Okay. There you go. So as I was saying in the last 6 weeks, so through May, June, and July, IBM Systems Australia and New Zealand will be running a series of business technical web seminar discussions, right? So the sessions aims to educate as well as enable attendees to understand the unique business value that we have in our portfolio. So the idea is to have like a 30-40 minute talk, and then more like 10 to 15 minutes to question and answers. In the end, I reckon that's the better way. If Andrew and maybe Patrick, putting you to work, Patrick, if you guys see some question popping up, just feel free to already answer so we can speed up the process, right? But I'm happy to answer all of them if we have time. Those are the duties. So we're the technical New Zealand technical team. We work for Systems AP. So we have Barry White, master inventor of our flash system. You have myself. You have Patrick Alton that wowed us last week with Linux One solution. So he's an expert on the topic. And we have Andrew G, which is our client technical architect for New Zealand and AP as well. Just a second, just to check if no one else from the panel is here. Okay, so shall we go? So here we go. We are in the session number 7. We are almost there. So as we promised from the beginning, we are delivering 8 sessions, 8 technical sessions that will be available for you guys later on YouTube. If you want to replay or some specific point that you want to talk about, the video will be uploaded like sooner today. Okay. Yeah, that's pretty much it from it. So next week we will have our last session about the Spectrum Protect Plus. So the session is backing up your application. The easy as click there, 1, 2, 3, right? So, I'm horrible with jokes. Sorry about that. But yeah, today the topic is about the 3 little solutions, not little, but 3 solutions from our storage portfolio. Okay, managing exabytes of data with Spectrum Storage. So today we're going to cover basically IBM Spectrum Discover, IBM Spectrum Scale, and IBM Cloud Object Storage, okay? And how they can fit together like a charm, right? But first, a little bit of background. As you may know, it is all about data. So I know this slide can be like updated with new numbers and yada yada. Yes, I totally agree. I will just highlight something that you may not notice. So first, that yes, we have heaps of data inside the house in my silos, but I don't understand this data. What I mean by that is that I don't extract the correct value of this huge amount of data. So it is like more data that we have, less we know about it, because we don't have tools and infrastructure smart enough to address that. The idea is to pick to reduce one thing that we call it enterprise amnesia, which is basically what is happening today with the siloed and old systems. So we have petabytes and petabytes all spread into our data center, but we don't extract value from it. So we just need to keep it for legal purposes. We don't know about aging. We don't know about maybe doing some mining on these data lakes and extract some knowledge to my business to understand my client needs a little bit better. So we don't have that properly. So there's a movement like started like 3-4 years ago to try to address that issue, right? So the idea of the tools that I'm about to show you is basically reducing the enterprise amnesia and increasing or raising the understood data that we have. So more data that we have, more understand that we have about our business, my business, and so I can offer to my client something more unique with added value, okay? So basically this is one thing of background that I would like to talk to you about. The other thing is what we call it context computing. I don't know if any one of you guys know about this context, this concept, but it is pretty easy. It is just data search for data, right? So I don't know if you realize that when you're doing an AI application or artificial intelligence application, in the beginning of the process, I have a huge amount of compute to spend, and I have a huge amount of data to be discovered, right? And on the beginning, it is very slow process because again, we don't have data. Let me explain this in another way. If I show you this piece of puzzle, are you able to understand the whole context of the knowledge that I'm trying to discover? It's very rare, right? So it is just a single word, bat. If I add another puzzle piece, you can say, oh, okay, so we have bat, we have another, yeah, so what? I still don't get the message. So, and then you get another piece of puzzle with nothing. So yeah, good idea. I still don't getting what you wanna say, Abilio. But slowly, as I am adding puzzle pieces to my big data AI application, the final information becomes clear. So then you have a full sentence. I duck it as the bat flew my way. Another exciting baseball game. Just a cut off from a news, right? The idea of IBM Spectrum Discover, Spectrum Scale, and Object Storage is to offer you this kind of knowledge from the infrastructure point of view, so your applications can be smart enough and it can be as efficient as it can be. So another point. So we talked about.
Just for a moment. Barry is on, and so is Pat, but they are attendees only. Can you make them participants, please?
Sure.
Or panelists?
Sorry about that. I can see Pat, but I can't see Barry. Oh, I can see Barry now. Yep. Sorry, Barry. Sorry, Pat. I didn't saw you.
My fault for going late. Sorry to interrupt.
No worries. No worries. Still have time. You can pay the bill after that. So we talked about enterprise amnesia. Yes. We talked about how we need a tool, or how do we need mechanisms to put pieces of our puzzle together. So that's also a good thing. But let me show you another example of a problematic stuff, right? So imagine that you have your marketing department within their own systems, with their own data storage, with sometimes years ago, I don't know if you guys remember, with their own backup solution, and sometimes even with an exclusive IT guy. And that was happening to every single department, right? So things were becoming a little bit better and consolidated from the management point of view, but still, if you realize today, we still have siloed systems for departments, right? So it is not an old stuff. It's still happening, and we still see them as different silos. Reasons for that? There are technology involved. If you are a media entertainment company, for example, there are very specific systems that run that business, right? So I have a few clients from this industry. So it is very, very clear to me that the tools that they run to do broadcasting, to do the 7 a.m. TV news on station, live or not live, recording, just broadcasting a movie that came from US studio. So there are very specific tools. Let's put it this way: the engineering on the TV station, but needs to talk to sales, and needs to talk to law to see if there is any restriction to if it's parenting guidance. And so all the silos need to talk, and that's a reality. Today, what we do is that we have specialists for all these silos, and we hope that they will work together, not only from the human resource point of view, but mainly from the technology point of view. Sometimes it just doesn't work, right? So data is separate islands, and it is costly, it is inefficient, and it is wasteful, because maybe what marketing is doing, sales is already doing, or engineering is already doing. Definitely IT is not doing any of this. But what I mean by that is that there are different departments, but they have a single goal, right? Because they belong to the same organization. Another piece of information that I would like to share with you now is customers are modernized applications, nothing new about that, but they are accelerating their cloud adoption. And when I say cloud, and this is a very old discussion, I don't believe cloud as a physical place, but I understand cloud as a concept, as a feature. So are you able to, even if it is on-premise or not, so the things are evolving in a way that today cloud cannot be considered as a physical place anymore. Well, only that, I mean, right? It can mean many other things. Oops, sorry. Oops. I reckon that. Anyway, I didn't know what happened here. So yeah, so they're moving to the cloud. That's not new. Enterprise, 75% of the companies will modernize existing application with the next 3 years. I can share you the source of this as well. 92% of the survey executives said that the most successful cloud enabled creation and support new business models. So yes, we are going to the cloud, and not only one cloud. The cloud that one cloud is better for one purpose than a cloud for another one. Okay, now is this one here. So what happened is that different silos, as I said, complex to manage, difficult or expensive to scale. Sometimes you may go to an old equipment, appliance based. It does the job, but it doesn't talk to anyone else. So you need to upgrade it. So you're not, or you have decisions to make. You can go lock to that proprietary technology, or you can open to something that something more not open source, but a standard pattern that more vendors in the market can talk to, right? So at IBM, it is clear message that hybrid clouds is a reality because of this, okay? So you may ask yourself, lots of data, how can I manage? Where is it placed? How can I automate analytics? What type of data do I have? Basic questions like this. How can I ensure data fidelity? Where is the latest version of this particular file? Do I have duplicate data in my environment? Very easy to. Six Sigma type of thing. How can I map this data to my business constructs? So the idea is that, yeah, I need to keep it, but why? So the idea behind all the technologies from the next slides will be to answer those questions, okay? So far, so good. Many questions, Andrew? No?
Okay. Nothing is yet. No, we're good.
Okay. So basically, just to show you that what we have, don't worry, I will not talk about every single box. It is only the three on the top right here. So we are data-driven type of company, right? So IBM today has a huge and complete portfolio to do block and file or object, whatever you have. We have a solution for it. Bear in mind that one size doesn't fit all. So it is clear that once you are engaged with us somehow, we are going to talk to you and analyze your data environment to see which solution will be a best fit, right? So basically, these three little guys here on the top right, it will be discussed right away. Spectrum scale. So yeah, so spectrum scale is formerly known for the old guys here on this call. It used to be called GPFS, or even before that, I reckon it was media management systems. Is that correct, Barry? I reckon it is more your age than my one. But so now we call it spectrum scale. Just an observation on what we call it. As you may see, we are calling almost everything spectrum something, right? So for this time, it is not just a marketing stuff. It is also a way of making easier to our clients and partners to understand the data management and protection portfolio. So you have the Spectrum Control to control data. You have the Spectrum Protect suite. You have Spectrum Discover, Scale, and Object. So it is all about data. So it is not only a marketing stuff, right? So just an observation of that. Getting back here, so Spectrum Scale, it is a file system in our portfolio and our unstructured data portfolio. So just some highlights of this guy. So performance, remove data-related bottlenecks, right? So it can be scale out, scale up, what fits you It can be cloud. So what fits you better, you can use the flavor that we want. So it is a parallel scale-out solution. You can have like demonstrated in lab 2.5 terabytes per second of throughput. So that's massive. So if you think about the amount of data that we have, it is an easy of management. So enable a global collaboration because we can have a single namespace. So for example, we are running some proof of concepts around here that one piece of the business is in Australia and another piece of the business is in New Zealand. So we are making in a structure that it can be seen by clients around the planet, around the globe, as a single entity. So from the management point of view, from the security point of view, that's a very good advantage, right? So economics, cost and performance. We're going to see that using our QoS on the project preview or team support, thing provisioning or data placement, we would call it tiering, will help you with the economics of this storage. We believe it is right data in the right place in the right time, right? It is robust. You can start very small and you can grow like up to 1.2 billions of files or maybe more. There's no physical limit as far as I know. There are some articles saying yottabytes that you can have it, but there is no data in the planet to see if that is a reachable limit or not. But anyway, I reckon that the technical term is heaps of data, so you don't have problems from the scalability in these regards, right? So you can start very small with a single entity to two little servers, one running a protocol node to talk to the world, another one running the NSD, which is basically the storage behind, right? So it is very easy to understand the architecture. And from that regard, it's very robust as well. You may laugh about this slide, but I like the idea of updated view. Simplified view is not that simplified from the amount of things that I'm about to just show. But the thing is, it is to show you that we support lots of things, right? So in theory, from the beginning, as a start, you have a global namespace, which we call it the main cluster, running in a Spectrum scale code that can have underneath lots of different tiers, right? So you can have a JBOD, you can have your flash drive for hot data, metadata, AI application in machine learning inference phase. You can have tape drives, you can have disk, you can have transport cloud tiering to maybe on object storage in the cloud or IBM Cloud, or maybe Azure if you have Azure in your site as well, or maybe AWS S3. But we also support, as we are part of OpenStack Foundation, we also support Swift, so you can just chunk the data in a cloud that supports S3 format on Swift. So that's also a very good feature from the flexibility point of view, integration point of view. Okay. As I said, it is a product that you can run your business around the globe. So you can use something called active file management, which is a caching sync feature from a Spectrum scale. So you can have like different sites in the planet having the same amount of information. And by the way, if you have in your business heaps of ingest points, like imagine one of my clients in Asia Pacific radio station, and every single region they have like 3 or 4 radio stations that they have ingest data point. So spectrum scale is used in this case to stop the data sprawling, which is basically bring your own device. That was happening in this client from regard. So small city, no infrastructure. The guy on the radio just bringing their external hard drive, and that's it. So once we put a spectrum scale to run over there, these stop happening. So now everything can be backed up, everything can be protected, and everything can be managed, right? So from the language point of view, let's put it this way. We can talk directly through your containers, Kubernetes, using our CSI driver. We can talk file, NFS and Windows SMB, or SMB, I mean, POSIX. We can talk S3, Swift, gave by Swift. And we can do a transparent HDFS if we are running in a Hadoop type of application, just like the one that we still running. I reckon in Australia, and they used to be my client in the past. We had a red Hadoop in the Spectrum Scale project over there. But you may ask, hey Abilio, I don't like the situation of having a huge infrastructure. I don't want to have more servers in my premise. I want this to run in a cloud. Can I do that? Yes. These are the options that it is currently supported. So you can run Spectrum Scale on AWS and IBM Cloud. So it is a way of making it more flexible. And also, if you want to do some mirroring between an on-prem and also in one of the cloud offerings, one of the cloud providers, yes, so that's a good idea. We need to check because there are some restrictions on the codes. Having the same codes integration discussed, that's perfectly possible, perfectly doable. It is very handy when you imagine that you may have budget for on-prem solution, but you don't have a budget for a disaster recovery type of thing. So yep, there you go. Spectrum Scale can help you with that. So from the middleware point of view, slash applications. So those are few of options that we already have clients running into it. So yes, you can have, we have a very close relationship with Hadoop, HDFS. As I said, you can run your Kubernetes, your container runtime environment. If you have a SAP HANA and your SAP HANA and it is using file as a repository, yes, you can use Spectrum Scale for that. A matter of fact, you can run a Spectrum Scale as a file server. It can do much more than that. It is not a direct use case, but it works. We have clients here. I have a client here in Auckland where we have like approximately 13 petabytes of data managed by Spectrum Scale, and we have like 1.2 billions of files managed and approximately 30,000 users. So yeah, there you go. They use as a file as well, file serving. Single management at scale. So as I said, you can start small and you can grow slowly. So with Spectrum Scale, it simplifies the management by combining the workflows on a single common enterprise data platform. Single namespace, eliminate redundant copies of data. So extensive monitoring analytics. You can add Spectrum Scale to be monitored by Spectrum Control, by the way. It has a huge scalability, like it is saying billions of files or yottabytes of data. easy to set up, improved performance. Okay, so store everywhere, run everywhere. So unified scale out data lake. So basically what we're talking about here, imagine this is Spectrum scale on green here. He is putting everything together. So the application will see a single namespace like a slash company slash data. And then underneath, we can have like one piece of these running on-prem, the other one on cloud as a clustering, right? So as a high availability solution. And you can ingest all types of data at the same time. So just a matter of curiosity, right? So global collaboration with AFM, so Advanced File Management, which is a file system caching in a name in a single namespace. So if you are running something in Australia, for example, and you want to replicate it to New Zealand, and where we are doing some studies in one of the industries that we attend here, we support here. We're measuring the minimum amount of link to make this happen as smooth as possible and as transparent as possible. So it can work, and we're just setting the expectations on performance. So that's pretty awesome when it is done. So disaster recovery is done by these high availability features that we have. And that's pretty much it. So, and as I said, just to highlight, if you don't, sorry, if you don't want to have it on-prem, don't forget that you can have it running on IBM Cloud or AWS, okay? Improve data economics. This is very fancy and makes a huge difference on clients' budgets, because we always want to be as fast as we can, right? What happened is that the fast storage, that is usually more expensive. And so we need to have a way of having the right data in the right time, in the right place. What I mean by that is, when I need speed, I would like to have speed. When I don't need speed anymore, I would like to put that data, to push that data into a layer, into a tier that performance is not required, but capacity is required, or even to offload to a tape library in the backend, right? So in this particular client that I just talked to you about like minutes ago, the 13 petabytes of data. So they have several tiers running. They have cloud, they have cloud object storage, they have tape library in the end, and they have several tiers within their block storage that serves as NSD NSD repository to Spectrum Scale protocol nodes. So the thing is that they're doing the right thing. They realize that most of the data, like more than 50%, was not hot data at all. And why you need a flash storage for this amount of data. So, and then they came up with a solution, which is tiered by Spectrum Scale, that could brought some economies to their environments, okay? So that's really, really good. And by the way, you don't need to have any effort to move data between one tier to the other. Once you define your policies, Spectrum Scale will do the job for you, right? So you don't need to be like an expert and moving data manually. Once you have set the policies, Spectrum Scale will do. So it's policy driven. Am I going over time? Okay. It is software defined, right? So why is that important? Because you're not locked into an hardware architecture. Spectrum Scale, as I said, can survive without an IBM hardware. We would love you to have your Spectrum Scale running into power servers, for example, because they are robust. They have a better MTBF number compared to Intel servers. However, if you want a cost-effective solution, you may be looking at Intel servers to run your Spectrum Scale platform. So no harm on that. It will work perfectly fine. Entergy now is wanting to kill me because he loves Power Server, but that's a discussion that we can talk about on the Q&A. But yeah, it can run on Intel, it can run on Power, it can run on the cloud. So it is software defined. So that's really, really important. It is not locked into an appliance type of thing that doesn't talk to anything else. So it is real software defined. So it comes all with all main features to be compliant to NIST certification. I wrote a red book like a few years ago about encryption and NIST 800-131, if I'm not wrong. So yes, it is supported. So you can do your cluster, and if you submit this for some certification, external certification auditing, you will see that you will be okay because we have this. We have the certification done. We have something called immutability, which is in tape world, we would call it write once, read many, warm. Encrypted, and you can manage by external key manager like SQLM. What else? So data dispersion and erasure codes. So Spectrum Scale can have a version which is, we call it erasure coding version, which will do something similar, not exactly, but similar to IBM Cloud Object Storage on how it protects its own data, right? There you go. So you can have as a software, you can bring your own server to run it. You can run as a integrated solution. This is what we call it elastic storage server. And yes, of course, you can run as a service running into our cloud providers. So some cloud providers as a service, so infrastructure as a service type of offering. Okay. Some value propositions here. So high throughput, low latency, data sharing across cities and countries, high performance, and that's heterogeneous storage hardware management. So if it is Intel, it doesn't really matter. You can buy your own flavor or your preferred flavor of Intel. Fast time to value, easy of deployment and measurement. So there's some good value propositions on that one. So from leading use case, I would say data intensive technical computing. HPC, we have heaps of clients here in New Zealand and in Australia running HPC environment on Spectrum Scale. They don't run it in anyone else. Second very good use case is artificial intelligence. Of course, I will show you a very fancy chart in a moment. Big data and analytics and Hadoop, things like that, okay? And yes, of course, if you want to run an archive type of repository and you want to run an Spectrum Scale, yes, you can have. But from the archive proposition, we may think that Spectrum Scale or object storage, which one will be the best for a particular case. As I said, one size doesn't fit all, right? The second guy, the Spectrum Discover. We have this guy a bit more than 2 years now. So basically what it does is bringing a structure to something that is not a structure, right? On the database, relational database, we used to have those functions and then stored procedures to put the data aligned, whereas the formalizing five Fs on the database. So it is very common technology to blocks to structured data. For unstructured data, that is not that clear. So IBM Storage brought a guy called IBM Spectrum Discover, which will do that for you. What is this guy? So search less, discover more, right? So the idea is to have a unified metadata management to do insight for iterations, files, and object storage. So it can point it out to an object storage, to a file system, if it is IBM or not, doesn't really matter. I will show you the currently supported ones. So basically what it does is discover, classify, label, and then find the data quickly, right? And making the search ready for applications, for example. So where? Basically, it can run, I can do this mining against Spectrum Scale, Spectrum Archive, Object Storage, Spectrum Protect, Elastic Storage, which is scale in an integrated version. But we are currently supporting Isilon, AWS S3, Ceph, and NetApp, right? So you don't need to have a Spectrum Scale to run Spectrum Discover. So what? Index, data tagging. So simplest deploy, metadata curation, custom metadata tagging in case your data is not previously tagged. I will show you some snapshots that I did. Content inspection, policy engine, and application plugin for your AI applications. For example, if you want to have a more defined view, your AI application wants to dig into your data lake to find a particular content, you may use Spectrum Discover to make this content ready when the application calls. So this runtime, it will be much faster than it used to be in the past, right? And so why? High-speed data insight, right? So large scale analytics, data governance, data optimization, and data management. So IBM Spectrum Discover, it really accelerates customer value by helping the client to find the value and to optimize and to go to have a proper management on the data, right? There you go, data mapping. So this is a copy, a snap from the GUI. So for example, easily to create a policy to tag some files, right? So at a time, so from now to 120 days, and file type MP4, WMV, KT, MOV, AVI. If that is a reality, tag as old video true. So, and then we save it, and then we can schedule to run daily, monthly, or just once if we want. But basically we can point it out to a data lake and find this information very easily for us, right? And then you can put it in a report. But it's not only that, you can use regular expressions, which is something very cool and one of the not unique about one of the special added value things that Spectrum Discover brings to us. So imagine that we are going to select the content, search the agent here on the agents. We select all of the regular expression that can be used to content search. We specify the data is not being shown just an existence of PI, personal private information. Imagine that I am digging into health data lake where I want to do research and get the information on patients with cancer, but I don't want to show DNAs, but I want to show what was done with some criteria like age, like medicine that was used, so we can mix and match this, and we can protect the identity with that. So that's no harm on that. It is very easy to do. So as I said already, said about the regular expressions, and just to highlight, can be used to detect the personal identifiable information, and also I said about health, but you can also be it can also be like a credit card information, email address to ensure that the data is compliant with government policies such as GDPR. Okay. Third one, as you can imagine, we're talking about now IBM Cloud Object Storage, which is basically a huge bucket and protected bucket of terabytes or petabytes or exabytes. So basically, you have your applications sending data to what we call it the assessor, which will slice to send to the slice store, which will basically protect the data in this particular manner. Oh, okay. I'm sorry about that. I put in one slide in front of the other. So that is basically the first slide, which is driving IBM Cloud Object Storage and so many data tolerance for the primary, secondary storage. So that's the basic discussion here is that a few clients are thinking that tape's not a proper fit anymore for a long time archive, and they want another solution with the same kind of reliability and resilience, right? So IBM brought IBM Cloud Object Storage. We bought this company a few years ago, and now it's part of our solution. But guess what? Our competitors will still say that tape doesn't matter. We don't say that because we have both. So you can pick and choose the best option for you, right? So efficiencies that make sense to your environment, you can pick or a bit of IBM Cloud Object Storage, a bit of tape drive. So you can pick and choose whatever you want. And then, yes, we go to a simple and secure architecture, three main bits here. So we have the accessor, you have the management node where you do your management stuff, and you have the slice store where the magic happens, okay? And then we go to this guy here. Build for extreme and easily scalable solution. So any to any. So it doesn't really matter if you have 1, 2, 3, 4 sites. We have an optimal number, call it 3 sites, where we do a geographic dispersed array coding, which I will talk about in a minute. But basically is we have the slice store layer, which is a scale out capacity. We have the access layer, which is a scale out throughput as well. So you are needing more throughput, you add more accessors, you need more capacity, you add more slice store nodes, okay? So it's very scalable from this perspective as well. And this is how we save the data. So we pick the data, we transform into encrypted one, and then we slice it. We add more slice to guarantee that that integrity of the data. And we guarantee, like in this case, IDA, which is we need 6 for reads and writes. So basically to protect 6 data slice. So we slice the data into small chunks, and we will protect it into different nodes. So this is how we protect data into object storage. So information dispersal algorithm, right? So as I said, imagine that we do a write, disperses slides in erase protection, site A, B, C. All the data is available on these 3 sites, and we have a fail, connection lost. So in that case, I still have access to the data, but hey, I have another fail on one of the nodes in site B. So yes, you have access to the data, and there you go, you have a third fail, and yes, you still have access to the data. So basically, you can have different types of reliability depending on how much slice do you have or how much IDA you set. This is not 12, 6, and 8 is not only a fixed stuff. You can have other options as well to protect your data. How it is bringing economy to your environment. Basically, if I have 3 sites, for example, this is a very common bit. You need to protect your data. For example, 1.8, 1.2 terabytes. So you, in a traditional storage, you will need to have 3 copies of these, a total of 3.6. With Spectrum, with IBM Cloud Object Storage, you don't need all that from the raw capacity point of view. You will need just a chunk of that in each side with a total of 1.8 terabytes. 1.8, yeah, in this case is 1.8 terabytes of 1 terabyte of usable data. So from that perspective, you are saving some money on the amount of drives that you need to protect your data, right? So just that. And every piece of this puzzle working together to deliver an AI application, for example. So in a data pipeline for AI, for example, we have the ingest phase, we have the organize phase, we have the analyze, machine learning, deep learning, and the insights out, right? So in those different phases, as you can see, AI applications will require a different type of storage. So having a single namespace for that is very handy, because it doesn't really matter where the data is. It will stay in a single namespace, and the application, the AI application, can go directly to one place instead of going to many other places, right? So basically, just an example of this, but I have many others that I can discuss in the Q&A if you guys want. Just a reminder that we will have some announcements next week. So there's an event called the Simple and Comprehensive Foundation for AI. Thursday, July 9th, 2020, 11 a.m. Eastern Daylight Time. A bit tricky for us. So, but I'll make sure that I will put the link on the chat here. Okay. I reckon that we can open for discussion.
Yeah, we've got a couple of good questions actually, Abilio. Edson D'Souza had a statement/question. He says, every time I listen to something related to the cloud, he wonders whether the network infrastructure will support the data traffic or whether it will be available. And as we said, the cloud isn't necessarily a destination somewhere else. A cloud could be on premises. He asks, what is IBM using to ensure the expected performance will be delivered, particularly on any data placement or migration processes? What kinds of features or technologies are we using? So if we look at, say, the ESS, for example, we tend to use very high performance InfiniBand networks to ensure that we get good performance within our solution. And obviously 10 or 100 gig Ethernet on the outside. But we also have IBM Aspira, which is a high performance networking or data transfer solution that we've got. So for example, I know we have a, what should we say, graphic effects company here in Wellington that uses Scale, I believe still, and they use Aspira to do high data bandwidth transfers back to the US to the head of the movie houses, etc. So hopefully that's sort of what Edson was asking. You know, what sort of technologies have we got to guarantee or guarantee the performance that we're expecting? So is there anything else that we've got that monitors within?
Well, very good question. I mean, we need to understand the data firstly, right? So we can't guarantee without studying the data, because as you said, network cards, yes, but also we need to ensure that the servers that are running the protocol nodes and NSD nodes, they have CPU and memory enough to cope with that workload as well. And from the storage point of view, we need to also guarantee that we have flash storage enough to do the hot metadata placement, and as well as object storage in any other tiers. I use at IBM, we have a tool called File and Object Studio Design, File and Object Studio, where we pick all the requirements, all the network capacity, if it is high availability clustering or not, if the IBM Cloud Object Storage will be running in 2 sites, 3 sites. So we pick all that information and we do like we used to have on storage for Disk Magic. We have this File and Object Studio to come with a minimum of hardware and software that we to run that workload. This is the, I wouldn't say that we guarantee, but this is the way that we size it, right? So we understand the workload and then we move on.
Yeah, plus we've got scalability. You know, if you need more performance with our solution, we can add more nodes in, either on the processor side or we can add it on the, on the capacity side. Unlike some of our competitive solutions who have big filer systems where all communication has to come through one node. So we've got advantages architecturally over.
Yeah, and this company is really important because sometimes when a client is comparing, like he's imagined that he's comparing apples to apples, but he's kind of having a small appliance model from our competitors while we are doing a scale out type of thing, and they ran out of capacity from the performance point of view very quickly, ran out of performance very quickly, I mean. And we're still doing our job. It may be a conservative approach, but it was working so far, and we're happy with that. Yep.
Yeah. Another question we have might be a little bit too specific for this, and we may need to get back to them. We have a Hadoop cluster accessing an ESS via HDFS with 100 gig Ethernet. With full access permission. Can we provision these portions of the file system by Hadoop cluster to selected Red Hat containerized pods via the CSI interface? No, that's reasonably specific.
I need to come back with that, but I would say that in theory yes, but there are some restrictions that need to be studied at this. So I would love to study the environment if you don't mind. I don't know who asked that, but just
Tang YH. Yep.
Yeah. So just send me an email. We can check all the variables on this. Yeah, happy to help.
Yeah, that's about it for questions as far as I can tell that have been submitted online. Okay.
Good. I don't know, Andrew, Barry, Pat, any comments on this? Apart from mocking me about the video on the YouTube video, any other questions, serious questions about the session?
Now, one thing that you did bring up, which eventually in there, was the fact that we avoid, by being an SDS, we avoid hardware vendor lock-in, and we are heterogeneous, and a lot of people don't understand that. You know, whenever we respond, obviously we respond with IBM storage, but we say you don't have to. We obviously prefer you to. Whereas some other competitive filer systems, you would be very, very hard pushed to put something else externally on their system. So they can be modular, but they're sort of monolithic because you have to buy their storage subsystem. So we're far more open, and we can get, you know, if somebody decides they're going to do heavens above, they're going to do an end of life on a storage subsystem and they need to get rid of a lot of it, then you could take advantage of those offers with the IBM. Obviously, you have to use the IBM file system over the top, but yeah, it's a good advantage.
Yeah, it is indeed. Thanks for. I reckon that I saved some words on that one, but yeah, definitely. So software defined has its advantage indeed, and yeah.
Yep.
I just pop it up the link of next week's announcement. So if anyone is curious to see what is coming on these about these guys, Discover and Spectrum Scale, just register. It is an online, of course.
We're looking forward to this week's promotional video. Abilio. I don't know what you got planned for this week, but you gotta go one better than.
Yeah, I don't know. Any ideas? Yeah, happy. We should do a poll about it, right? So what should be the next video?
You can pay homage to another movie.
Believe it or not, that was my fourth attempt. So, and then when my neighbor passed by, I said, "Yeah, no more. I need to get his authorization, and that's it. That will be the one." So, guys, if any comment more, so can I wrap up here?
Yeah, it's all quiet on the Western Front.
So thanks for coming, and any questions, just send me by email. I'm happy to get engaging in any unstructured data projects that you guys are running. Next week we will be running our last session on our IBM systems back to school. I would like to invite you. There will be a very special event. I'm already missing our planning sessions from months ago when we were deciding to do this. So yeah, if you don't have anything more to do on a Wednesday afternoon, if it's raining, and just come and let's talk about backup, and I'm happy to, as usual, to get engaged in your projects. Don't forget to fill the survey, to watch the replay if you want, and also the material is already on the box folder of the event, okay? Kikaha Matewa, see you next week.